they're equivalent. So, here we go. I'm going to get a single equivalent force here. Single force resultant Y with positive downward. It's going to say 100 plus 200, that's 300. That's the single force resultant in this system. Some moments resultant, and I'm going to take it about A. You can take it about any point you want. Of course, on the test, I'm going to make you take it about the point I specified. Why? Because I want everybody to have the same answer. So, some moments about A resultant, and I'm going to take clockwise positive. This is 400 plus 200. M2 is 400 minus 200, because this is clockwise, this is counterclockwise, plus 200 times 10, plus 100 times 5. The single moment A resultant is 2700 clockwise. Now, anything in A through E that creates a single force of 300 down and 2700 counterclockwise is going to be equivalent. So let's see. First one. Some force resultant Y is 300. Check. What's some moments about A resultant? Clockwise positive. That's going to be this P1, which is 300 times its distance of 5. And this moment, which I know is 200, I just tack it on. This moment A resultant is 1700 clockwise. Is that equivalent to the original beam? Nope. That's a big negatory. Okay, what about B? I got P1 300, M1 2700. Hell, I don't even have to calculate. Yeah, it is. I don't have to calculate it. What about this one, C? Some forces Y is equal to 300. What's my moment A resultant? Some clockwise positive. That's going to be 300 times 9, which is 2700 clockwise. Yes, that is absolutely. Next one. Over here, some forces resultant Y equals 0 positive downward. This has a downward and an upward, by the way. That's going to be minus 100 plus 200 minus 100 plus 300. Single force resultant in the Y is 300. Okay, the forces are equivalent. What about the moments? Some moments about A resultant clockwise positive. That's going to be minus 2500 plus 1700 plus 300 times 10 plus 200 times 5 minus 100 times 5. Net result, moment A resultant is 2700 clockwise. Is it?
Yes.
Yeah. This one right here, if I sum forces resultant Y, I'm going to get minus 1500 plus 2000 plus 500 minus 500. Single force resultant Y is 500. I don't even need to worry about what the moment resultant is because this force resultant doesn't. So that's a no, that's a yes, that's a yes, that's a yes, that is a no. So if I had a sensing, feeling beam, all the yeses, the beams couldn't decipher between the loads. Internally, they're all different. Externally, they're the same as far as the beam is concerned. B, C, D as the same result, external result, as the original beam. Now, beam, if it was a sensitive field beam, could not decipher the difference. You with me? Internally, they're all different. So we're talking about external, not internal. Got it? That was the question I just got through asking you today. Hey, how do I know if two systems are equivalent? Force here must equal force here, moments here must equal moments there. Okay? Next problem. Turn the page. We haven't done this one. It says, replace the system of force by a single force passing through O in a couple moments. Can this system be replaced by a single force? Well, then, can you answer that question? What was the question I asked you today? Hey, what three systems will always reduce down to a single force? Don't need the damn litmus test. We said they were concurrent, coplanar, and parallel. What the hell do you have here? Bingo. So I know this is going to reduce down to a single force. So what I have here is this system. 200, 300. That's system one. I'm saying I can always reduce this down to a single force resultant and some moment resultant, which I now know says, hey, I can reduce this down to a single force resultant, system 3. So there are three systems. Original system with the three forces. I can reduce that down to a single force, single moment, anytime I want. That's a fact. Then the question becomes, can I reduce this down to a single force? And the answer is yes, because I know it's a coplanar system. That always reduces down to a single force. All right, what is that single force? So I need to know what these guys are first. Easy. I come in and I create a little table, and I say magnitude, x component, y component, and then moment about O, and I'll take positive CW clockwise. All right, so what I have here is 200, 300, and the 100. I am then going to sum the x's here, sum the y's here, sum the moments about O resultant here. These guys here are going to have components, 1 in the x, 300 cosine 60, and 300 sine 60. This guy over here is going to have a 200 times 4 over 5 x component, and a y component of 200 times 3 over 5. Agreed? What am I using? What concept of statics am I using here? When I take moments of the component, what? Varignone's theorem, yes. It's much easier to do Varignone's because I know what the distances are from here to here. I know what the distances are from here to here. There. 6 in the x and 4 in the y. All right, so this I should have 160, 120. Here I should have 150, 260. Here I should have 0 and minus 100. Please don't forget the minus. It is acting downward. If I sum these, I'm going to get the x value, 310. Sum this, I'm going to get the y value, 280. Moments. Okay, I'm going to do 8 times 160 positive minus 120 times 2 to give me 1040 positive. Here I'm going to do 150 times 4 minus 260 times 2 to give me minus 960. Here I'm going to do 100 times 4 to give me a plus 400. So this 160 is this guy, 160 in the x. This is 120. So the x value, I take it back here and I need this distance. Well, that distance is the y, which is the 8. That's why I multiply it by 8. The 120 is the y value, and I need this distance here. That distance is the 2, which is the x value. Agreed? That's where I'm getting these numbers from. So if I sum this, this, and this, I'm going to get 480 clockwise. I'm going to get 480 clockwise. Now, does the litmus test really work? Well, what I'm saying to you is single force resultant is 310I plus 280J. My moment at O resultant is a minus 480K. Why am I saying minus? Because clockwise, by the right-hand rule, is a negative K. Counterclockwise is a positive K by the right-hand rule. That's why I put a minus 480K. Well, if I take single force resultant dotted with moment O resultant, do I get 0? Yeah, because I with K is 0, J with K is 0. Because the only thing that survives in a dot product is I with I, J with J, K with K. Any other combo is 0. Agreed? Who's not with me? Now, I can find the single force resultant. Single force resultant is the square root of 310 squared plus 280 squared. Single force resultant is 417.73. Theta is equal to tangent inverse of 280 over 310. That's equal to 42.1 degrees. In the first quadrant. In the first one. Why? Because I got a positive x and a positive y. The only place you have a positive x and a positive y is in the first quadrant. Agreed?
Oh, that's supposed to be a
Who's not with me? Now, what I have done is I've found exactly system 2. System 2, 417.73, but it's not straight down. It is up at an angle of 42.1 degrees. My moment is 480 clockwise. That's what I just found. System 2 exists. It always exists. Single force is 417.73 at an angle of 42.1 in the first quadrant. And the moment is 480 clockwise. Does system 3 exist? That's a single force. Yes. Well, where the hell do I place that single force? Well, moments here must equal moments there must equal moments there. So, I'm going to come in and I'm going to say, here's my xy. I'm going to put in 417.73 at an angle of 42.1 degrees. I need this perpendicular distance. That's what I need in order to place it. Moments must equal moments. Moments of system 2 must equal moments of system 3. Well, that's 480 must equal to 417.73, right, times d. D is equal to 480 divided by 417.73. That gives me 1.15 feet. So I know this guy is 1.15 feet. and I just locate it. Now, I cannot put this force here. I cannot put it there. Why not? Because it will create a counterclockwise rotation, and I don't have that. I have 480 clockwise. You with me? That's how you find the location in a 2D problem. If it was a 3D problem, then I'd set the determinant where the R is x, y, z, and the force would be the force resultant, force x, force y, force z, and then equate the moments in system 2 to the moments in system 3, solving for x, y, z. You with me? Here is 2D, all I need is a d. I just found 1.15 feet from my moment center, which is O. How do I know what? I have to create a rotation that is clockwise. That's why I know it's there. If I put it here, yes, because it will create, so it's either in quadrant 1 or 2. So you have an option. All right, questions? Moving on. Next one is important for you. So if you're sleeping, time to wake your ass up.
You got a picture of that, right?
Because this is very similar in idea to question number 3. But it doesn't have everything in question number 3. It just says, hey, for this system, can you please reduce it down to a single force, single moment? And is it possible to reduce it down to a single force? Okay? And here what you see is two forces, two things. One, a force F1 that is along B to A, and then you have this couple or moment that is acting along A to B. So F1, C1 act along this line. Got it? One is going B to A, the other going A to B. So the moment is going B to A because the double arrow goes, in essence, from A to B. The other one, the force, the 140, goes from B to A. So the first thing, it's a 3D problem. What's the first thing I do? Coordinate system. X, Y, Z. That is not Hitler's, but it's definitely a right-handed coordinate system. Correct? All right. Did I give you alpha, beta, gamma?
No.
No. Did I give you double projection?
No.
No. Did I give you a bunch of distances?
Pretty much.
Probably have to go through the 5-step process. For at least F1, because this is already an IJK format. This one is just parallel to my Z. So it's easy. This one's easy. F2 is minus 80K. F3 is 40I minus 30J plus 0K. Those are the easy ones. C2, or this moment couple, whatever you want to call it, that's going to be a positive 400J. Why? Well, because I'm going to put my thumb along here, and that thumb is pointing in the positive J, which is turning this way with my right hand. The only thing I don't know is F1 and C1. Well, I need the coordinates of B. I need the coordinates of A. Coordinates of A are 6, 3, 0. Coordinates of B are 0, 0, 2. 5-step process. Here we go. R, B, A. That's XA minus XBI plus YA minus YBJ plus ZA minus ZBK. That's RBA is equal to 6 minus 0, 6i. 3 minus 0, 3j. 0 minus 2, minus 2k. Magnitude of this BA is
Bless you.
7. 6 squared, 36. 3 squared, 9. And 4. So, F1 is equal to 140 times 6i plus 3j minus 2k. Divide this by 7. That's going to give me 120i plus 60j minus 40k. Bingo. There's F in terms of IJK. Any 3D problem, you must get everything in IJK format. It's that simple. There's no, what do I do with this? I gotta get it in IJK format. What about C1? C1. Remember, C1 is going from A to B. I have the position vector RBA. I really need RAB. What's... Yes! All I have to do is negate RAB, I'll get RBA, right? You have RBA, negate it to get RAB. So here's my R, and here's my unit vector. So really, this is going to be 700 times a negative 6i, a negative 3j, a positive 2k, and it's still going to be divided by 7. Yes? Which is really going to give me minus 600i minus 300j plus 200k. Bingo. So what was I doing here? Hey, did you remember that RAB is the opposite of RBA? Did we state that someplace? Yeah, it's in your damn notes. So what happened? I put this in a problem. Did you remember that? If you didn't, you'd be doing position vector BA, and you'd end up with the same thing. All you did was you wasted about 30 seconds for no reason. So when I tell you every little damn thing is coming at you, I ain't gonna miss a beat, I'm not lying to you. I know for a fact, in your notes, when we did position vector, one of the facts, fact number 1 I think, is that RAB is the negative of RBA. True or false? There it is, come back to haunt you. All right, so what's my single force resultant? Well, my single force resultant would be F1 plus F2 plus F3. What? I just add i's, j's, k's together. If I do that, I'm going to get 160i plus 30j minus 120k. What about my moments? Well, it said here, do me moments at A. And on the test, it's going to tell you, do me moments at some point. That way, your point will match my point, and I don't have to worry about doing a moment about a different point. Do I have to do it about A? No. I can do it about any point I want. But I'm doing it about A, so we're going to do it all together about A. Some moment A resultant is equal to. Well, I've got two moments, C1 minus 600I minus 300J plus 200K. This is C1. Then I have a plus 400J. That is C2. Moments, you just dump in. You don't multiply by, it's a moment already, dump it in. Now the question becomes, hey, what forces that you have there are creating moments at A? Is F1 creating a moment at A? Is F1 creating a moment at A? again, the question is F1 creating a moment at A? There should be a resounding ring in this room. Fuck no! That's what should be resounding in my ears, but I don't have anything like that. I have one voice here, one voice there. Every single one of you should know that F1 creates no moment about A. Please, somebody tell me why it doesn't create a moment at A. Why? Yes, its line of action goes through the moment zone. What would D be? 0. No D, no moment. So this guy's creating no moment because its line of action, it's A. Alright, so that means plus. This guy has a line of action this way. So this would be RAE crossed with F2. Plus, this guy's creating an RAD crossed with F3. Those are the only other forces that could create a moment. There's only 3 forces. One of them, F1, line of action goes through, does not create a moment. I just created a moment that F2 is created by doing this, and this is the moment that's being created by F3. Agreed? Now I literally have to do the damn determinant. So let me set up the determinant. You don't really need to, but here it is. I, J, K. What is RAE? The easiest is A to E. That hits the line of action of the force, and that's easy because it's negative 6I. So negative 6, 0, 0. Oh, I love zeros in my determinants. And F2 is 0, 0 minus 80. That was easy. This guy right here is the determinant IJK of, I need an R. The R is this guy, RAD. Well, how can I get there? I can get there by going down, right? 3 over 2. That'll get me there. So this could be I, 0, negative 3, and positive 2. And then the force is 40, 30, negative, and 0. Now you gotta do the determinant. This is why we did the vector algebra review. I assumed nothing. I assume you don't remember. I assume you don't know. But we all put you on the same footing by reviewing the vector algebra and how to do a cross product. Yes? No bitching and complaining that I didn't know how to do that. Because I taught you how to do that. I didn't assume a damn thing. As a matter of fact, most of the time I assume they don't know. Or I assume they don't remember even if they do know. That's generally what I work for as an assumption. They don't remember or they don't know. That's why we taught you how to do this. So, in essence, what I have here is moment A resultant is equal to. If I do all this, I should end up, after I do everything, minus 600I, minus 300J, plus 200K, that's my C1, plus 400J, that's my C2. Then this guy is going to generate a minus 480J, and this guy is going to produce a plus 60I, plus 80J, plus 120K. So this right here is that. This right here is that. And the others are already there. So moment A resultant is going to be minus 540I, minus 300J, plus 320K. There's my single force, single moment in the boxes. Now, how hard is it to get a single force, single moment? Hey, give me everything in IJK. For the forces, add up I's, add up J's, add up K's. Then for the moments, you might have to do R cross F for the forces that are creating moments. Get everything in IJK, add up I's, add up J's, add up K's, done. The question becomes, hey, can I reduce this down to a single force? Well, here's where the damn litmus test comes in. Moment A resultant down to a single force resultant. If you do that, it does not equal 0. Therefore, not reducible. Therefore, not reducible. And on the test, that's all you have to do. Do the dot product and tell me it is not reducible. Questions? So, subtlety came in because I made sure that C2 was the opposite of F1, which in your mind should have said, oh, RAB is the negative of RBA. I don't have to do a whole lot. Heavy, F1 is creating the moment. Why? Because the line of action goes through the moment section. These were things that were in the notes, in the videos. Here they come back to bite you in the ass. Did you not pay attention to the videos? Did you not take the notes? Did you not study the notes? It's probably you didn't study the notes. That's why you don't know. If you didn't know. What? What's that? When it's I crossed with K. Yeah. Okay. This problem right here is really, what we just did right now, is really part E of question number 3. That's only part E. Holy shit. Now, you're sitting there, you should know this. You should fucking know this. What is question number 3 going to say? Part A is express all forces and moments in Cartesian vector form. Bingo. So let's write it out. So to make this a question 3, it's going to say part A, express all forces / moments in Cartesian vector form. Somebody tell me what part B is going to say. Damn, I'm giving you the test question before the damn test gets here. I'm out the bill. What a son of a bitch I am. Tell me what question part B. Oh shit. You want to phone a friend? Phone her. What's part B going to say? Find what? I already said find the force. Part B. Come on, Drury. What's part B going to say? Find what? Find a moment. Take one of these freaking forces. It doesn't matter which one. Of course, on the test, I'll pick one for you. We're going to say, find moment about, pick a point. O, the origin of F3. Find the moment of F3 about O. Well, what do I got to do? I need an R that goes from O to F3. Right? I need an R that goes from O to F3. There's the R. What's another way of getting there? I'll go over this way and down this way. Over this way means I'm going 6I, and this way plus 0J plus 2K. Crossed with 40I minus 30J. Do the cross product, you have the answer. Right? Okay, nails. Tell me, what's the next question, nails? The reason I'm asking nails is because you're working with your nails. Do they need a manager? Then we should get one. Yeah, let's do it. So what's the next question, Nels? You see how we in my neighborhood came up with nicknames for people? What's the next question? I don't know. Ay, Chihuahua. Chihuahua. Yes. No! Put your hand down. Mr. Know-it-all. We gotta give people that don't know a chance. Then I'll come back to you. We'll form a friend and you'll be the friend. Alright? What? I can't hear you. Speak up. Project, my son. That would be part E. I already did that part. Give me something else in between there. Go ahead. Come on. I know you want to tell me something. Tell me something good. He's thinking. I can see the wheels spinning. They're spinning hard and go, damn, he picked on me. Motherfucker. What? You can't think of holy shit. What, Mr. Red?
It might be find it.
Might be? There is no freaking might be. We should know. Go ahead.
Find an equal between.
No! Yes! Part C. Project F1, or let's go with F2 onto line AB. What do I need? I need unit vector AB, right? Which, by the way, you already have, don't you? Don't we have the unit vector AB? Yeah. Dot that with F3. How hard was that? Next question. Come on, tell me. Tell me. Anybody? Go.
The moment of that force on that line.
Yes! Part D. Moment of F2 about line AB. Part E. This is part E, what we just did. I just told you that this is only one piece of question number 3. Here you go. This is question number 3. There is no question what you're going to get in question number 3. Question number 3 should be 10 out of 10 for everybody. You know what's coming. The only thing you don't know is what's the diagram look like. But it's going to say, hey, express all forces and moments in Cartesian vector form. Hey, find me a moment about some point. Hey, project a force onto some line. Hey, find me the moment of that force about the same line. Hey, reduce the system to a single force, single moment. Look at all 7, not 1, not 2, but all 7 of the damn tests that you have in the testing manual. They all say the same thing. Okay, granted, the line might not be AB, it could be AE, it could be AC, it could be whatever. The forces aren't the same. But it's going to say pretty much the same concepts in there. There should be no question what you should be doing for question number 3. None. Now, will you get 10 out of 10? No, because you're going to be sloppy. How are you going to be sloppy? Give me one example of sloppiness. All over the place. That's not good enough. Give me one place where you got sloppiness. On question number 3, which you already know the question. The only thing you don't know is what's the diagram look like. Give me one sloppiness. Huh?
He took that from me. I had the same error.
100%. You're going to fuck up the side. That's why you won't get 10 out of 10. Give me another one. Mess up the cross product. You don't get the math correct. Now, cross product is screwed up. Yeah. 100%. The coordinate system. You didn't pay attention to the coordinate system. Did I or did I not say, hey, I can use any coordinate system I want as long as it's right, I'm good to go, correct? So those are all possible errors to get you away from 10 out of 10 on question number 3, because you know what the question's gonna say. Yet I still get people saying, oh, Nora's out to fail people. What the fuck? How is Nora trying to fail you? He's given you 7 sample tests. He's told you exactly the verbiage that's going to appear on question number 3. Exact. There's no doubt. Yes. What? Yeah. Yes. What's the question?
I was looking at the help session question.
Help session question. Which one?
This one.
Yeah, that's a good one. Because that's an old question number 3.
I keep on seeing like these questions where it looks like they have a moment in a plane.
Oh, they're beautiful, aren't
I
they?
know you have to use
They're
it.
awesome. I love them.
Good to know, but how exactly like value do you have to use that?
Does everybody understand his question to me? Obviously, we're going to cover it in the help session, but I can cover it now. It's not a problem.
Yes, please. That'd be really cool.
If it was not seen by you, you would know what to deal with or how to deal with some moment that's arbitrary there. Indeed. So am I trying to fail you? I'm showing you. I am? No, 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 no. Hey, I keep seeing these stupid ass moments on the diagrams. So he's referred to something that looks like this. And let me put X, Y, Z. Right? He's saying, hey dude, I see these stupid moments that are sitting here like this, 200 Newton meters, pound feet, I don't care what the units are. How the hell do I deal with that? Or I may see something that is sitting like this on this plane, 400. Or I may see something that looks like this on that plane. How do I deal with that? Take your right hand. Take your right hand. Let's assume this is the top of the box, which is what I'm showing. Top of the box. Take your right hand. Sit right here. Curl it around like it shows. Okay, so I'm doing this. I'm curling around here. Where's my thumb pointing? What's up? So what you're telling me is this is 200J. If I'm down on it here on the bottom plane, so this is the bottom plane right here, right? There's the bottom plane. It's curling like this. Where's my thumb pointing? Negative 1. So that would be minus 400J. Next, this is on the side of the plane, right? So this is the side of the box right here. Side of the box, curl. Where's my thumb pointing?
That's right.
In that direction. What is that direction based on the coordinate system? Negative X. Positive X this way. When I curl, I'm in that direction. So this is minus 400I. This is minus 200J. That's what you're referring to, right? That's what you're referring to?
Yes.
Okay, I just answered your question.
Thank you.
You're welcome. What? Yeah, you. Yeah, F1 is going through the moment center because the moment center is point A, so it creates no moment. Yep. Any questions? Other questions? POSs. Now what do I have? This is not minus 40J and plus 40J. This is a couple separated by this distance. Grab the arrow, turn. I have a turning effect which is like this. Where's my thumb pointing? Into the page, which is negative Z. So this would be, if this was say 6 feet, the moment would be 6 times 40, which is 240 in the K direction negative. Got it? Who don't got it? Alright, let's move on. I got one more problem to do before we go into distributed loads on Thursday. Oh, by the way, here's a wrench. I am not going to test you on wrenches. I have it here. It's complete with the steps to get the wrench down to a single force. Okay, and I give it to you step by step by step by step. I give you an example. So here's the steps to go and reduce a wrench to a single force. Here's an example of a system that I can reduce down to a wrench. And you can see what I did. But I'm not testing, but I want it there in case down the road you were asked by some teacher to talk about wrenches. So I'm moving on to this one. It says, replace the following system of forces by the simplest possible. Well, what's the simplest possible for this guy? What's the simplest possible? A single force at a known location. Why do I know that? Because it is parallel and covalent. We get a double whammy here. So what I'm going to do is I'm going to take this original system, that's system 1. I'm going to reduce it down to a single force resultant and a moment A resultant. That's system 2. And system 3 is some force resultant at some distance x. That's going to be system 3. I know system 3 exists because we talked about, hey, there are 3 systems that automatically reduce down to a single force at a known location. That system are, or the 3 of them are, concurrent, coplanar, and parallel. Well, this is definitely going to go down to system 3. What's my single force? Resultant. In the y, because all the forces are in the y, I'm summing with positive downward. That's going to be 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 plus 40 plus 45. Single force resultant y, 225 downward. 225 downward. That's the single force resultant. What's my moment A resultant? Well, I chose the moment at A. We're going to take a moment at A. By taking a moment at A, I eliminate that 5. Why? Its line of action goes through the moment center. Gone. Each one of these forces is, according to this, 1 foot apart. So this is 1 foot, 1 foot, 1 foot, 1 foot, 1 foot, 1 foot, 1 foot. So I'm going to say some moments A resultant clockwise positive. That's going to be 10 times 1 plus 15 times 2 plus 20 times 3 plus 25 times 4 plus 30 times 5 plus 35 times 6 plus 40 times 7 plus 45 times 8. Moment A resultant is 1,200 foot-pounds clockwise. So I now know, hey, this is 225, this is 1,200. I just reduced down to single force, single moment. Now the question is, can I reduce down to single force at a known location, which is system 3? The answer is yes. What I need to do is I need to locate that distance x. I already know what the force is, 225. How do I find x? Hey, moments in system 1 must equal moments in system 2 must equal moments in system 3. Correct? What are the moments in system 2? 1200. What's the moment in system 3? 225 times x. X is equal to 5.3 feet from A. Done. You just located the force to generate equivalence between all three systems. So if this is a sensing, feeling being, it cannot decipher between all of these forces, 5 through 45, or a single force of 225 acting with a moment of 1200, or a single force 225 located 5.3 feet from A. Does not know the difference between the loads. Externally. Internally, a whole different animal. They're not equivalent internally. Okay? But these are system 3, system 2, system 1, all equivalent externally. The beam does not know the difference of how you loaded it. Couldn't tell you the difference. Now, please note what I just did is really, in essence, the center of gravity. We just found the center of gravity of those forces between 5 and 45. That's what I just found. The center of gravity is 5.3. So when you did center of gravity or center of mass back in Physics 1, you were applying the concept of equivalence and didn't even know it. Which is not your fault, it's the fault of the teacher that taught you the equation. Remember, what is the equation? The equation for center of gravity is simple. X or Y is W1 x1 plus W2 x2 plus W3 x3. Divide this by W1 plus W2 plus W3 plus dot dot dot. Well, guess what? This is force times distance, force times distance, force times distance. This is force. But if I take this over to the other side, I'll have W total times X bar is equal to summation Wi Xi. Now, you might not have seen it as W, you might have seen it as M for mass, but we know W is equal to mg. So mass is equal to W divided by G. Well, if I put W divided by G and W divided by G, the G's are going to cancel. So whether you use mass or weight, this doesn't frickin' matter. Because G's will cancel out. So you probably saw, and I think you probably saw it like this, maybe in physics. X bar is equal to M-I-R-I divided by M-I. Might have seen it like that. Go back into your physics textbook and see that that's probably what you saw. Instead of weight, you probably used F. That's all a factor of G anyway, so it doesn't matter whether you use mass or weight. You with me? Hey, what you doing on the phone? What are you doing? Huh? You're on Instagram. Instagram is so important, especially right here, right now. What was important? What were you watching? You what? You were lost. So I'm lost, fuck it, I'm not going to pay attention, I'm going to turn to Instagram. Instagram's not going to save me. Not at all. Again, when I tell you, I'm not going to fail you, you're going to fail yourself, it's the fucking truth. So I'm lost, I'm going to go to Instagram. Well, if Instagram has answers, I'm all for Instagram then. Hell, I'll get an account. How many on Instagram? Why? Why? What's that? I like the idea. What? Why is she laughing so hard? She's like going nuts over here and laughing. It's an inside joke. Now everybody fucking wants to know what the inside joke is. You guys are laughing way too hard. You want the rest of the class to laugh hard too. What? I don't have TikTok. What, Rodriguez?
What's the quiz for this?
Wait, I can't hear the Rodriguez guy.
What's the quiz for this week?
Speak.
What's the quiz for this week?
What?
Quiz this week. What is it? The quiz.
Oh, vectorology.
What?
What? Let me spell it out for V-E-C-T-O-R-A. Vector algebra. Oh my God. Not that hard. You guys are killing me.